This episode is brought to you by Battleborn Batteries, the best name in the RV and marine industry. These lithium batteries are designed and assembled in the USA, backed by a 10-year warranty. The best solution for your battery anxiety, so go check them out at battlebornbatteries.com.
Whether your adventure is on the road, on the water, or off the grid, Battleborn Batteries keep you out there longer.
Hi, everyone. This is Kenny, and I am so excited to announce that SnapPad has become a sponsor for the show. It means so much to us to have their support. I purchased SnapPads for our RV over 2 years ago, and I can honestly say if something happened to them today, I would replace them by tomorrow. They have saved my back and setup time by not needing to crawl underneath our Class A to set up blocks under our jack stands. They truly make setting up our RV a snap.
For me, they reduce vibration in the fifth wheel, took 15 minutes to install, and never come off. SnapPads also add a little something extra to the appearance of the jacks. Go check them out at rvsnappad.com.
You are listening to Beyond the Wheel, a podcast about the people and ideas that drive the RV community forward.
Hi, everyone, and welcome back to Beyond the Wheel. This is going to be a unique podcast. We have Rick Larson with us. He is a mechanical engineer and inventor. He worked in aerospace for many years and has parts on many planes and spacecraft, including satellites and the Mars Curiosity rover. When he retired and started RVing, he did not like the fact that he had to unhook his tow vehicle from the motorhome if he had to back up. So he invented a part to avoid the problem. In this episode, he talks all about the invention process. We hope you enjoy it, and we will see you on the other side.
Hi, Rick. Thank you for coming on the show today. Could you tell us a little bit about yourself and your role with the Backslider?
Sure. I'm a mechanical engineer. I graduated from the University of Central Florida about 1 million years ago. I spent most of my professional life in management, but I never stopped inventing. I've got 13 patents, and the last 2 were on our topic today, the Backslider. Most of my work has been in aerospace. I'm losing track here, about 20 some odd years ago, we started an aerospace company here in Tennessee. I was with an aerospace company in Florida for quite a few years. We started our company here in Tennessee, and it grew into the whole aerospace field. We have products in military aircraft and spacecraft. The International Space Station is kind of a fun project that was involved in the part of their environmental control system. Mars Science Laboratory, Curiosity, we've got 5 components in that, boogieing around Mars. Almost every aircraft that starts with F, as in Frank, F-16s, 22s, 35s, and that sort of thing. I have a lot of space junk left on the moon and on Mars and in orbit and spy satellites and all kinds of fun stuff. So it's been an interesting life. But about 9 years ago, I sold our company. We had a motorhome. Before that, we had a couple of fifth wheels. When we got the motorhome, we ran into an interesting problem, and that's what sparked the development of Backslider.
And we actually have you at an interesting point. I believe that you are the first guest that we've had where the Backslider is not on the market yet. So we're getting you at a pretty early stage early to us. You might have been involved in it for a long period of time already, but early for us that this is something that's not on the market yet. It's still, you're getting it to market. Is that correct?
That's correct. Yeah. It's about 6 years of development. It's in a stage now where we're seeking a licensee to manufacture it. Been approached about a dozen companies that are all related to the RV industry. They build some type of mechanical devices for the RV industry. And we've talked to about a dozen of them. There are 4 of them that are interested in it. They're looking it over. And unfortunately, this happened right at the start of this COVID-19 situation. and everything had to go on the shelf. So it's been very quiet since then. They've got the information, they're looking it over. But the device is completely built, it's developed and engineered and ready to go. It's one of the things, it's something that I wouldn't build because I'm retired.
Can you tell us what the problem was and then what the Backslider is as a solution?
The problem is that when you have a dinghy or a towed vehicle, essentially, connected to a motorhome, you can't back it up. Now, if you go onto the forums, you find all kinds of answers to this. And some people say, yes, I've backed it up 100 feet with no trouble. And others say, well, I've destroyed my tow bar, destroyed my car, my front steering. But that's an issue. It's a very, very complex issue in the front geometry of any type of vehicle that runs on the road. And it's the problem you have with the dinghy itself. Its front steering system, its front support, it works just great going forward. But when you push it backwards, connected to another vehicle, and that's the kicker right there. When it's mechanically connected to another vehicle, the wheels will eventually rotate very sharply, very quickly, and they'll jam. And when that happens, it happens so fast that it usually damages something within either the tow bar or the steering system on the towed. So that's where the problem occurs. So I ran into the problem several times when we bought our first motorhome, just getting stuck at one place or another where we had to back up and had no choice, and wound up having to disconnect. I'm one of those who will not back up the dinghy or towed. I'll disconnect first and back the one vehicle and then back the other and get out of the situation.
I am in the same boat now. But as you know, I shared the story with you that I backed up a couple times with no issue. But then there was a time that Sabrina and I tried to back our RV up with our car attached, and I destroyed it. It doesn't take much. I just bent part of our tow bar, and it wasn't able to be repaired, and it cost us about $1,000. And I know that you've been collecting information on other people's stories and experiences of backing up. What are some of maybe the worst case scenarios? Like how much it cost Sabrina and I $1,000. We were lucky in the fact that we were only a couple miles away from where we were going. So she just drove the car. We got there and we were able to order another tow bar, and it arrived before we needed to leave again. But I'm sure in some people's cases, not only are they causing damage and paying for it, but it might be even costing them time out of their trips and things like that. Is that what you're finding?
Yep, that's exactly what I've come across. There's not a lot of discussion on how expensive the damage was, but there are quite a few reports of damage itself. Now, yours about $1,000. I've found some others that run up to around $800 to $1,200. There was a story in Motorhome Magazine's 2018 RV Oops Awards, which
I never heard that before.
Oops Awards, and it's kind of amusing. But on the other hand, I admire this fellow who reported in the fact that he had $600 worth of damage to his steering. He had electric steering on his vehicle, like most new cars have today, and it damaged the steering wheel position sensor. The old hydraulic steering still gets damaged. It gets torn up pretty good, and the front geometry gets torn up. But it looks like the damage is going to be somewhere between $600 or $800 and several $1,000s, depending on how fast you go at it and how sure you are that you're going to succeed and that sort of thing. Because the faster you go at it, the more severe the damage will be.
So it sounds like maybe damaging the tow bar isn't quite as bad as if you just tore up the front suspension of your tow car.
Yeah, that's what it looks like to me. If you look at the electric steering EPS systems, the electric power steering systems, they are quite sensitive. You have a motor You have a position sensor, a steering sensor. So there's quite a few delicate components in that. And if you take that system and you swing it rapidly and bring it up against its mechanical stops, the sensitive components in that steering are going to get damaged. And they're pretty expensive to replace. The tow bar is going to get damaged. And if you damage the tow bar, you really have to suspect everything else that's involved in the tow bar, the device that it's connected to, on the motorhome, the nuts and bolts and fasteners, your plate on the vehicle, on the dinghy. All those things are suspect when you do that kind of damage. So you can replace the tow bar and put a new one on, but you wonder just how bad was the rest of it.
When you're towing a car or a truck, will your application work with any type of vehicle, or will it only work with certain types of vehicles?
I designed it to work with the vehicles that are specified in Motorhome Magazine, the towables. Motorhome Magazine and FMCA Magazine both list towables each year. And I designed it to stay within that range. That goes up to the fairly large 2,500 size trucks. And I've got a GMC 2500 HD, and it works with it. All the way down to the smallest towables. That's the range that it was designed for.
Does that mean that the Backslider is one device kind of fits all? It covers that entire range. There isn't several different sizes?
Yes, that's correct. It runs through the whole gamut. I haven't had a chance to test every vehicle in the series, but I've tested the upper end and Jeeps. I did most of my testing with a Jeep and a JK, and it worked great with that. Then a friend of mine has a smaller Jeep that we've run the test with, and I've run the test all the way up to a 2500 HD GMC pickup, a very heavy vehicle with a diesel engine and front wheel drive and everything. And that's a 2,200 pounds per wheel on the front end, and it worked.
Wow.
I'm curious about what the testing involves. You said you had a friend that tested his Jeep. I would imagine he's probably a pretty good friend if he's willing to destroy his Jeep.
Well, he is a good friend. He's a neighbor. He has a motorhome. They travel and they tow their Jeep. But he's kind of looked over my shoulder over the years. I've built this and I have a fairly extensive shop here, and he's kind of popped in from time to time. And he's watched me test with my Jeep, and so I don't think he was too nervous about it.
I'd like to point out too, with the Backslider being that it is a one device kind of fits all, that somebody could switch out their vehicles. I have a 2013 C-Max right now. If we wanted to switch cars, the Backslider would work on our new tow car as well, and not have to replace the Backslider. I think that's a kind of an important part. But I also wanted to ask you, going back to damaging components when reversing. So the big thing is that the front wheels of the car can sometimes kick while backing up, and then that's what causes the binding. I've heard of people saying, well, just have somebody jump in the driver's seat and hold the steering wheel. And in my mind, I always think, all right, well, that would be Sabrina. I'm going to back up the vehicle. Sabrina's not very strong, and I would worry, I don't know if this would happen or not, but I would worry that the wheel could try to turn or twist while she's trying to hold it or fight it and then get injured trying to do that. I always thought that was a bad suggestion from people. Have you heard of anything like that happening?
There's several items on the forums about people attempting that, and even pretty large, pretty strong men trying to hold a steering wheel and find it just spin out of their hands. The problem is the amount of load and leverage that the motorhome has over the dinghy. There's so much mass with the motorhome that it overpowers any attempt like that, even with power steering on. And if you lock the steering, let's say you just absolutely found a way to bolt that steering wheel so it isn't going to rotate, what happens is that the tires, the front tires and the back end of the dinghy are going to get out of alignment. If you absolutely lock the steering wheel, the tires would skid. They would rotate and skid sideways. But we don't lock a steering wheel like that. With the idea, it seems to be a first idea, an intuitive thing, where let's just grab the steering wheel and force it to go the way we want. It isn't going to work. As soon as that front steering gets a few degrees out of alignment from straight back, it goes violently against the stop. In fact, it only takes about 4 or 5 inches of rearward motion to go from center all the way to completely against the stop. There are a couple of occasions where a woman has tried to hold the steering wheel, had it spun violently. And of course, when you're holding a steering wheel like that, you've got a death grip on the thing trying to really hold it. And then it spins so rapidly that your brain can't get your hands to release the thing in time. She wound up with 2 broken wrists. So it can be pretty serious stuff. I strongly recommend against it.
Okay. That's what I tell people too. I never really heard of stories of it going wrong, but when I heard people mention that, I said, oh, I just think that just sounds like a disaster waiting to happen or an accident waiting to happen. So I'm glad that you actually know of a story where it has gone wrong. Man, that's terrible.
I didn't realize only 4 or 5 inches of movement could produce that violent of a turn in the wheel.
Yeah, it's to do with the position of the intersect. It gets kind of into a lot of engineering jargon, but the kingpin, there are 2 kingpins on the steering that the front wheels pivot around. That kingpin axis, if you project it down to the road, and it's just an imaginary projection down to the road, it makes contact right near the front of the tire contact patch. The contact patch is where the tire itself actually plants itself on the road, and that's a spot about as big as a man's hand. And that intersection of the kingpin is right at the front edge of it. The tire pivots around the center of the contact patch. So when you take a little measurement on it, you find that the kingpin intersection is only about an inch away from the center of the contact patch. As you back up, that angle changes very rapidly. Just the slightest movement backwards, and now you have the full inertia of the vehicle and the motorhome wanting to spin that tire. And the loads involved are tremendous. There are hundreds and hundreds of pounds of load causing rotation. So you just can't beat it. Even with power steering, you can't fight it.
Yeah, I can kind of imagine what you're saying. So then how does the Backslider resolve that issue?
The Backslider is a carrier. It's a device that gets the front wheels off the ground and takes over and overcomes the caster and the mechanical trail. Those are the 2 things that cause rotation. It goes in and creates its own caster, a reverse caster, by having a pair of, I hate to confuse this word because there are 2 uses for the word caster, but the Backslider has a pair of casters like you see on a shopping cart. But these are heavy-duty casters. And those casters are at the forward end of the Backslider, and they face toward the rear. You back the front wheels onto the Backslider and until it goes up and hits a stop, and then further load against the Backslider will cause them to start sliding. At the back end of the Backslider, the back end is sitting on a pair of ceramic plates. So as the front wheels of the car come up onto the Backslider, and they roll very easily onto it, and they start pushing it, the casters on the Backslider will allow the Backslider to steer, and the ceramic plates on the back, which are helping to carry the load along with the casters, will act like a drag. So they're kind of like a drag anchor that you'd put on a boat if you wanted to keep the boat pointed into the wind, for example. They overcome the caster of the vehicle, which is not like little shopping cart casters. This is the slope of the steering kingpin axis. They overcome the caster of the dinghy and force the steering wheels, the 2 front wheels, to steer the way they're supposed to. In other words, the front wheels will steer pretty much the same direction that they would if you were making that same maneuver going forward. They do steer slightly one way, they steer slightly another. If you want to make you want to back into a driveway, for example, make a 90-degree turn, they would steer the same way that they're going to steer when you come back out of that driveway. As you if you backed your motorhome into a driveway using the caster, using the Backsliders, and then you you drive off the backsliders and put them away, and you drive forward and come out of that driveway. The wheels will follow on the dinghy will follow the same path, and that's really important. So that when you end your backward travel, your wheels are pointed in exactly the direction they should be to go back forward again. If they were not, they could very easily jam in the same way they jam when you're going backwards. It's kind of strange, but they will go completely against the stop going forward if they're too far out of alignment. So the backslider just keeps them aligned in a proper direction all the time going backwards so that you can get off of them and then go back forward again.
So the only time you actually connect the backslider is when you want to back up.
That's correct. You have them stowed in the basement of the motorhome or in the back of the dinghy or wherever it's convenient. They're not very big. They're only a couple of feet long and they're about 16 inches wide and 4 inches high or something like that. So they're not a large thing, and they weigh about 20 pounds, so they're pretty easy to pick up and carry around. And you place them behind the front wheel and then back onto them. So that's the only time you use them. If you have to back up, you drag them out, you put one behind each front wheel, and then back on up, and you slide right up onto them, and you just keep going. So once they're there, you back onto them, and you just keep backing on up. And now the car behaves as if it were a trailer. So what the backslider is doing is just carrying the weight of the front end and keeping the front wheels in proper alignment.
So then does I'm trying to picture it a little bit. You place a backslider behind each front wheel when you back up. So is the backslider have a tilt down to it, and then once the wheels get onto it, it levels out?
No, it stays exactly in that position.
Okay.
The end of it that you back onto is very close to the ground. It's only about an inch off the ground, and that's where the ceramic plates are. So as you back onto it, the ceramic plates offer a lot of friction with the ground. And so they keep the backslider in place. So as soon as the wheel gets onto the backslider, those ceramic plates are keeping the backsliders pinned to the ground. As you roll forward, then now you start to distribute some of that wheel weight toward the casters that are at the front end of the backslider. So now you really have 4 points of contact. You have 2 casters in the front, 2 ceramic plates in the back, and that spreads the weight of that wheel out. Once you hit the stop on the front of the backslider and the load is a little bit lighter on those ceramic plates, you start sliding. The ceramic literally slides on the pavement. It makes a little scuffing on the pavement. You see a little white powdery dust, which is just the top grains of the shell and material that's in the pavement itself. That blows away with rain or wind or cars going by. But it's just enough drag that it keeps the wheels pointed in the correct direction.
What about gravel or dirt surfaces?
No, it won't work. Not at this point. We're looking at a way to make that happen, but at this point it's strictly for hard surfaces. Typical pavement, asphalt, concrete. It works real well on those surfaces.
Yeah, that was my next question about asphalt. So it'll work on asphalt?
Oh, yeah.
I know you said it took you about 6 years of development. Can you kind of walk through what those 6 years look like? Was it like a couple years of pen and paper and then a couple more years of actual build time? Can you kind of just step us through development?
The first year or so was where most of the conceptual development came about. I'm kind of a hands-on, intuitive sort of inventor, and the first thing I wanted to do was try something. I made up a steel slide because I thought the problem was with the front wheels, and that maybe if I just had them slide, that would take care of the problem. And so I made up something that slid, the wheels drove up onto it, and it was just steel against pavement, and found out that there's tremendous friction between steel and pavement, and it rips the steel up pretty quickly. And the problem is the backsliders weren't oriented in the correct direction. They slid along and they pointed left and they pointed right, but they didn't align so that I could get back off again. I had to climb in and start forcing the steering wheel around. The next thing I tried was I had the bright idea that maybe something ceramic might work. So I went to we have a ceramics company not too far from here. And I said, what's the hardest ceramic you have? And the tiles, these are ceramic tiles. And went back and glued those onto the steel and drove up onto the ceramic and found that the pavement just eats those ceramic tiles to pieces. So that didn't work. And there was another bad idea. So then as I decided maybe I ought to apply engineering to this. I grabbed what's called a Mohs table. It's a table of hardness of various materials and went up the scale. One of the materials that's on pavement is silicon dioxide, and that's very low on the Mohs scale. So I said, all right, what's higher on the Mohs scale? And aluminum oxide is way up there, and it's fairly inexpensive, and I've done a lot of work with alumina. So I found a company to send me some alumina plates and bonded those on, and wow, that worked. But I still had the problem where I didn't have any orientation. The wheels just slid along. They went left, they went right, and they weren't pointed in the right direction. So that prompted the next idea that maybe I didn't need alumina. Maybe I needed some kind of rolling friction and some casters on the front of this gadget. So I went into a complex bunch of mechanical design and built a rolling clutch. That worked, but it was too complex. So I said, well, let's go back and put the aluminum on the back. And finally, we hit the idea. 2 casters on the front, 2 alumina plates on the back, and that was the combination that worked. And most of that was in the first year. After that, it was a matter of making them more and more practical, working out bugs, and understanding the problem. I had a good friend of mine when I graduated said, Rick, he was an engineer, he said, the first thing you need to keep in mind is that you can't solve a problem you don't understand. And it took me a while, but I realized that I did not understand what was going on with the front wheels and front steering. So it took a little while to grasp the whole thing, get the whole picture, and then start fine-tuning the design so that it was, first of all, it was elegant in the way it worked, and then it was manufacturable. So that's what the remainder of those 4 years were involved in.
You did all this work in your shop? You didn't have to send any of that out?
No, I did it in the shop. I've got a fairly complete shop. I've got everything from acetylene to oscilloscopes in there. So it's fairly complete. I work in quite a few fields of engineering. So it wasn't a problem to machine up the components that I needed and bond them. Bonding the ceramic was one of the biggest challenges. Ceramic does not like to bond to anything because of its particular characteristics, its negativity. So it's kind of like trying to stick Scotch tape to bacon. It just
I've never heard that before, but I can easily picture how difficult that would be.
It doesn't want to stick to anything, but I found a company that specializes in adhesives, and they did have some surface treatments that work really well. So we got past that really complex bonding issue. Yeah, it was mostly a matter of making the thing manufacturable. I found out partway through that there were bending situations, and this is basically a steel fabrication. It's a frame that involves chrome moly tubing and steel tubing and other things like that. And there were things that I could not do in normal manufacture, so we had to make a few changes and make a few new models. But we finally got the thing quite manufacturable.
We'll be sure to put a couple photos of the Backslider on the website, and on our website, I should say, in the show notes. But I'm also curious, you said that it has 2 patents. At what point during that 6-year period do you apply for the patents? Is it that, do you wait till you have something complete and then say, okay, this is ready to patent? Or do you need to patent as you go along?
Well, the patent office has changed its regulations. It used to be first to invent. In 2010, I think it was, the rules changed, and now it's first to file. So really, at this point, you just have to not disclose the information as you're developing it, and then you can file at any point. I wanted to make sure that the thing worked before I really went into apply for patents, and I applied about the 3rd year into it, 2.5 years or 3 years into it. I don't recall. The second patent was a methods patent. The first one was a machine patent. But they both cover the device. One covers the physical characteristics of the device and the way it works, and the other one covers the actual method itself of doing it. And those patents take a while to issue, and they're horrifically expensive. I don't suggest that anyone just apply for a patent to have a patent. It's $8,000 to $12,000 roughly. It depends on how complex you're getting into, and for each patent, and then it takes 18 months or so to get it through the whole process. Yeah, they're expensive.
So from there, what would you say? I know with COVID-19 going on now, I think you had the Backslider up to different manufacturers. You were shopping around. Has COVID now become the most challenging part of getting this to the market, or how has that affected it? And what are some of the other maybe more challenging points that have affected the process?
Well, the COVID has just slowed things down. It's just kind of put a halt to everything because most companies shut down pretty much, and then so when they're out like that and they're down. If we just talk about normal times, the biggest challenge is to hit a company when it's ready for a new product, to find a company that's ready to begin something new that's in its field, that it can manufacture, that sort of thing. I wouldn't want to approach an awning company, for example, and see if they'd be interested in selling this. It just doesn't fit them. But there are companies that, for example, tow bar manufacturers, that sort of thing, that fits their field, and they have the infrastructure to build it. They do welding, they do tubing fabrication of one sort or another, they do machining, and they do assembly work and painting and finishing, coating, that sort of thing. So it fits their types of fabrication. So then it's a matter of finding the right companies, and they kind of fall in that category. And if you look around the RV, most of the RV facilities, the retail facilities, you find the types of companies that you're looking for. And then it's a matter of finding the right company at the right time. Are you guys ready to put a new product to market? And they may look at it and say, this is a great idea, but we're bringing something to market right now, and we've got our money and time invested in it, and our guys are pretty well tied up. They may be interested in a year from now. So it's just a matter after that of timing, just finding when somebody's interested in doing it.
So right now you don't have you can't estimate a timeline of when you think it will be for sale.
No, it's a little tough because of COVID. The guesstimates are tough. I would have said sometime around 2022, but in this, the way it is right now, it's a little tough to know. Like I said, I had 4 companies that were interested in it. One company seemed to be quite interested, and they were kicking it around, looking it over with their engineering teams and their new product development groups, and didn't come to a conclusion. And then all this mess hit. So it's kind of it's going to sit on the shelf until they're ready to get going again. And they have a lot of problems to work out getting back into production.
Once the manufacturer kind of has it and the company, is it out of your hands at that point, Rick, or are you involved in the marketing of it? Where does your role fall once it's in the manufacturing stage?
In most circumstances like this, the manufacturer takes over. Some manufacturers want their team completely involved in it. They may come in and make some changes to it. They may even rename it. Every manufacturer has their own decisions on that sort of thing. Backslider was a kind of a working title for me. It's just something that seemed to fit. But they'll pretty well take over. Now, there's a tendency these days for some of the more modern companies to, if you have a background in this sort of, if the inventor has a background in this sort of thing and some experience with it, to work with them or have you work along with them to get it to market, but not involved in selling and that sort of thing. It's not like promoting a book, I have to promote it and I have to work very closely with the publisher. But a device like this, they usually take over and want to handle all aspects of it.
Okay. That's very interesting. That's very, very cool. I guess originally when I was speaking with you and we were going back and forth on emails, in my mind anyway, I was thinking, oh, he's creating a whole new company. Your company's going to be building this, but this is more of you developed the idea, you built the prototypes, and then you get a company to purchase it from you. Am I understanding that correctly then?
They'll license it from me.
Okay.
Patents and the technology. I have a complete drawing package on it. We've done finite element analysis on the components, and all the manufacturing steps have been worked out. So my background is manufacturing, so this stuff is not, it's fairly straightforward, and I pretty much know what can be done and what can't be done in manufacturing. So we worked it out, designed it so that it's manufacturable. But they'll take it over and make it fit their structure, their manufacturing capabilities, or they may decide to farm it out completely and to somebody else, or farm out parts of it. And that's really up to the manufacturer themselves. I'm available because I have a background in manufacturing, background in aerospace. I'm available to work with them or to just step back. For
a retired guy, you certainly sound awfully busy.
Yeah.
Well, it's fun. I can't imagine retiring in front of a television that's incomprehensible. So it's fun having a shop, and when an idea comes up, I see what I can do to work it out.
So until this product comes to market, the only other option for people right now is to unhook and do the backing up and then hook it back up, right? I mean, there's nothing else like this on the market right now.
No, there isn't. It's kind of strange. We've had motorhomes towing dinghies for the past 50 years or so, roughly, because they really kind of began in the 70s. In that time, there have been some attempts at making devices. There was an attempt at a device that lifts the entire front end of the vehicle off the ground so that the wheels aren't touching. The mechanics of doing that are tremendous, and it really upsets the balance and the stability of the motorhome. You can't just crank several thousand pounds in the air and put it way back on that on the tail end of the motorhome, way behind the rear tires. That device works, but it's tremendously expensive. And in our patent searches, we found that, and that was pretty much it. There was nothing else. We did a pretty extensive patent searches on it.
And this seems like it's a very, I don't know if efficient's the right word, but it's a very efficient and probably low cost way for somebody that flat toes to be able to have this capability.
Yeah, it's compact. It's easy to carry. There are some videos on my website that show it in use and show it in operation. So anybody that wants to see how it works and see what it looks like working. And my neighbor was great in hand with that, and so I could do the videoing. And I'm not good at video, so it's kind of kludgy, but we did manage to piece it together. And there's 3 videos there that show it. One just going straight back on the road, another backing up through a long curve on my driveway. Is about a 45-degree curve, and still another one those will give some idea of how it works and what it's like to carry them around. They're easy to pick up, and they're lighter than a suitcase by far, and easy enough to carry around. And they stow. You can toss them in a trunk of a vehicle, or in the back of a Jeep, or in the basement of the motorhome.
I would like to see a video of your shop.
Oh my gosh, now you're talking about a mess. Oh, gracious. Woodworking and metalworking and electronics.
Well, I like the idea a lot. I like that what Shauna brought up too, that there is no fix for this. It's literally, if you need to back up, you got to take everything apart, back up, get back in the position that you want to get into again, and then hook it back together. I think this is great that you are working on a solution for this, and that I love simple. I really like that it's simple and it's not a mechanical thing where you're jacking anything up. You just got to, you just place these behind the back, the front tires rather, and you just back right up onto it. It sounds very simple to use, and I think simple is always best.
It is simple. It's simple in use, and so it's back onto them and just keep going. You're pretty much backing up a trailer with a motorhome. That's a little tricky in itself, but because the motorhome the motorhome has a long, real long wheelbase, and your car typically has a short wheelbase, and that's kind of the opposite of what you like on a convenient. If you look at a semi, you've got a long trailer and a very short tractor, and that's the easier combination to back up. But it's very doable. You can see in the video, my neighbor never used these things before. He jumped in. He didn't even have a camera working. He did it strictly by mirrors and backed up around a long curve. And he did another backup where he backed up into my driveway and then pulled back out again. So, of course, like with a trailer, you could jackknife it and crunch everything all to pieces. But I think we have enough common sense not to do that.
Yeah.
All right. Well, we'll have to link out to those videos then too. We'll link out to your site so that people can check out the video and see it in action.
That'd be great. That'd be great.
So, Rick, before we let you go, is there anything we missed or anything you would like to add, or are you working on anything else that's going to surprise us?
I wish I was. No, my next project right now is working with my wife on a small display cabinet. So the metalworking equipment sitting on the side right now. But as far as advice, the only real thing I would say is don't ask your wife to sit in the dinghy and try to hold the steering wheel. Somebody's going to get badly hurt doing that. Disconnect and do it the right way. There's really no point in trying to damage your car or damage your tow equipment, particularly on vacation. That's a lousy time to mess things up.
That's true. That's good advice. Very true. Well, thank you very much, Rick, for coming on. We really appreciate you sharing the story and the process of how everything is going. I learned a lot. I learned a lot every time we interview somebody, but this was very enjoyable. I really liked it.
Yeah, thank you so much.
It was fun.
How cool of a story is that? To have an aerospace background and having equipment on the International Space Station to developing a new product to solve the issue of backing up a tow car. I feel as if the solution is in very good hands. We talked a lot about what a backup disaster could cost, but we did not talk about the time. When you damage your car, RV, or tow bar in this type of incident, I think it is important to remember the time needed to make repairs and get replacement parts. This is certainly not an event you would want to have while on vacation. We appreciate Rick taking the time to come up with not only a solution, but also for taking the time to chat with us. I really feel like we have the exclusive on this item, since it's not even out in stores just yet. I think I have also found my new favorite saying. It's like trying to apply Scotch tape to bacon. I will be using that often from now on. Take care, everyone. Safe travels, and we will be back in 2 weeks with Sun RV, where they tell us all about their new luxury RV resort in California called Costa Vista RV Park. This is actually another exclusive, as the park is not set to open until early 2021. This episode is brought to you by Battleborn Batteries, the best name in the RV and marine industry. These lithium batteries are designed and assembled in the USA, backed by a 10-year warranty. The best solution for your battery anxiety, so go check them out at battlebornbatteries.com.
Whether your adventure is on the road, on the water, or off the grid, Battleborn batteries keep you out there longer.